Good morning, students. I, Jeevan Kumar Pandey, welcome you all once again to the next session of the electrostatics chapter. So, if you remember, students, last class I just introduced the Coulomb's law, and I told that next class we will be practicing some of the numericals. But before we practice the numericals, one very important property pertaining to Coulomb's law that I'll discuss today first, that is principle of superposition. Principle of superposition. Now, what is this principle? Coulomb's law that we have discussed in the last class, that actually relates force, Coulombic force, electrostatic force between two point charges. But suppose we have a system of charges and we have to find a net force on a particular charge. Suppose here I have charge Q1, charge Q2, here I have charge Q3, and likewise we have many particles having charges. Say we have n charges Q1 to Qn, and we wish to find the net electrostatic force on a charge capital Q. Then this principle of superposition says that to find the net force on that charge capital Q, we just have to find the vector sum of all the individual forces that would be exerted on this charge Q by the other charges. For example, Q1 will exert some force on Q. It may be attractive or repulsive. Suppose that force I indicate by F1 vector. So F1 vector is the force exerted by charge Q1 on Q. Likewise, Q2 exerts some force on Q. Let that force be F2. It can be again attractive or repulsive. So let us consider a general case. So this is F2 vector, and so on. Say this force be Fn vector. Now from principle of superposition, we can write the total force on this charge Q as F net Fq is the force on charge Q. That is the vector sum of F1 vector, then F2 vector, then F3 vector, and so on till the last one, that is Fn vector. This we can write in the form of summation as summation Fi vector, where I runs from 1 to n. So this is the mathematical formulation for principle of superposition. It is a very important tool, students. If you are given some combinations for charges and you have to find the net force on a particular charge, then we will be using this principle of superposition. So far principle of superposition and then Coulomb's law together, they will be serving as important tool for solving most of the numericals. Let us see some numericals to understand the concepts that we have discussed so far. The first question that we would like to discuss is a very simple one. This is the question. We have to compare the gravitational force and electrical force, electrostatic force between an electron and a proton. So let us denote the gravitational force as Fg and the electrostatic force as Fe. Gravitational force, you know students, between an electron and proton. Now here separation is not given. We'll assume that the electron and the proton are separated by distance, say r. The gravitational force between them will be G times mass of electron into mass of proton divided by square of distance between them. Likewise, electrostatic force, you know students, in vacuum 1 upon 4 pi epsilon naught charge on electron, which we write as E. Charge on proton is also same. Of course, they have opposite signs, but here we are writing the magnitude of electrostatic force. It is attractive in nature because they have opposite signs, but I am writing the magnitude upon r square. Here I have used Coulomb's law, 1 by 4 pi epsilon naught q1 q2 by r square. Now for comparing them, what we can do, we can find the ratio Fg upon Fe. So this will become, put the values, G mass of electron, mass of proton, r square divided by this term. So this will invert 4 pi epsilon naught times r square upon E times E will write as E square. Now here most of the things are constants whose value you have to substitute, and then you will get the relation between them. One thing you can note here, as I have told in the beginning of the question, that the separation between them is not given, and in fact that is not required, because as we see here, the terms r square will cancel. Now value of gravitational constant 6.67 10 to the power minus 11. I will leave that part, calculation you can do yourself. 4 pi epsilon naught you don't know, but you know 1 by 4 pi epsilon naught. If you remember, I have told the value of 1 by 4 pi epsilon naught. You can review the last lesson. Its value is 9 times 10 to the power 9 newtons per meter square, Newton meter square per coulomb square. You know the value of charge of electron, mass of proton. Put all these values, you will find that the ratio Fe by Fg, you will get Fg by Fe. You can take the ratio Fe by Fg. That ratio will be nearly 2.4 multiplied by 10 to the power 39. Now see this value, students, see the power 10 to the power 39. This is indeed a very large value. What does this indicate? This indicates that the electrostatic force Fe is quite large compared to gravitational force. We can write that Fe is this big number multiplied by Fg. If you remember, in the beginning of this session, the first class which I have taken, there I have given some hint that electrostatic force are quite stronger as compared to gravitational forces, and here is an example for that. Okay, so are you ready for the next question? So let's discuss our next question. The next question figure I have shown in the text, shown on the board. Here you can see there is a square. Each side of the square is A. This is the center of the square O. 4 point charges q, small q each, are placed at the corners of this square. Another test charge, capital Q, is placed at the center, that I write as Q. You have to find net force on charge Q. This is our second question. Looking at the figure, can you guess the answer, students? So we have to incorporate the principle of superposition here. First you have to think which are the charges that would exert force on this central charge. Let me name these vertices as A, B, C and D. We assume here, it may be given in the question also, but anyway it does not matter, that both these charges Q and Q are positive. Small q and capital Q, both we take as positive. But this holds true even for the case when both of them are negative, or one of them is positive, other one is negative. Either the forces will be attractive or repulsive. All these are like charges. This may be like, this may be unlike. I am taking an example in which both of them are like charges. So they will repel. A will repel this charge Q. The direction of force should be like this. And this I will write as F of A vector. Is it clear, students? If the charge at A and the charge at center will be in opposite direction, then the force will be attractive in nature. Likewise, FB, B will repel Q in this direction, C will repel Q and will exert a force in this direction, and D will exert a force in this direction. Can you see the figure and judge whether these four forces FA, FB, FC and FD, these four vectors, is there any specific coincidence between these four? I think you have guessed. Their magnitudes must be equal. Why? Because the pair of charges remains same for all the four pairs, and the separation is also same. So let us call each one of them to have a magnitude F. So this is FB, this is this is FB, this one is FD, and this one is FC. Consider FC and FA. These two forces are having equal magnitude and they have opposite direction. Therefore, they will cancel each other. Likewise, these two forces FD and FB will also cancel each other. So I write FA vector and FC vector. What relation we should write here? FA vector and FC vector are equal in magnitude, so I put equal sign. But they are in opposite direction. That opposite direction must be indicated by a minus sign. Likewise, I can write FB vector is equal to minus FD vector. Therefore, net force on charge Q from principle of superposition, you can write there, from principle of superposition, the net force on charge Q will be given as sum of the individual forces, that is F1 vector plus F2 vector plus F3 vector and plus F4 vector. Instead of 1, 2, 3, 4, I should write FA vector, FB vector, FC vector and FD vector. Now you can see FA vector is minus FC vector. This implies FA plus FC will be 0. Likewise, FB plus FD vector will also be 0. So this term is 0, that term is 0. Total, they will add up to a 0 vector. Instead of doing so, remember students, whenever there is a case of symmetry, This is a symmetrical figure and this charge was placed at the center. In cases of symmetry, you can guess that the net force on this charge placed at the center of that geometrical figure should be 0. So we are ready to proceed for the next question. Here goes the next question. The question reads, how should you distribute a given charge small q between two bodies so that the electrostatic force between them is maximum? This again can be solved on the basis of Coulomb's law. Let us see how to solve this question. We are given some charge q. It is to be distributed in two bodies. Out of charge q, to the first body I give some charge, say x. Then what will be the charge on the next body? Of course, q minus x. Is it clear, students? Now the question is, how should this distribution be done so that the force between those two charges is maximum? So let the two bodies be having charge q1 and q2. q1 I have written that is equal to x and q2 is equal to q minus x. For any given separation R, what does Coulomb's law say? It says that the force of attraction or repulsion between them is having a magnitude given by the formula 1 upon 4 pi epsilon naught product of charges divided by square of distance between them. So this becomes 1 upon 4 pi epsilon naught. Product of charges will become x times q minus x and divided by r square. Here r is constant, remember. We are solving this question for a given separation. What is the variable, students? Here the variable is x. So we have to find x such that f is maximized. So for this force f to be maximum, this force F will be maximum if this quantity. Why this quantity? Because I told R is fixed and this is also a number, 9 times 10 to the power 9. You know that, Newton meter square per Coulomb square. So the only variable factors are x and q minus x. So that product, if it goes to maximum value, this force F will also go to maximum value. So for F to be maximum, the function x times q minus x should be maximum. I'll choose this function as fx, f of x. Now if fx is to be maximized, then its derivative d by dx of fx must be equal to 0. Let me remind you, students, particularly those who belong to biology group who have not opted for maths, that if there is any function and we draw its graph like this, then at the points of maxima or at the points of minima, the slope of tangent. Now, what should the tangent look like at this point? It will be having some slope, but at the point of maxima, the tangent will be like so. At the point of minima also, the tangent will be like so. If the tangent is like so, do you think it has any slope? So this is fx and this is x. So we say at points of maxima, the tangent does not have any slope. Its slope is 0. Mathematically, slope is nothing but dy by dx. If this is y, we write the derivative of y with respect to x is nothing but slope of the tangent. So this I think you can understand, keeping this in mind. So d by dx of the function is y here, so we have written dy by dx, the function is fx here, so we have written d by dx of fx, that is equal to 0. Now let us try to solve this. So d by dx of fx will become how much? Q times x minus x square. We will multiply it. This derivative must be equal to 0. This implies q is a constant, so term by term we will differentiate this. Q times derivative of x becomes 1 minus d by dx of x square. Do you remember, students? Twice of x is equal to 0. So this implies q is equal to 2x, solving which we will get x is equal to q by 2, and that gives us our answer. Of course, now you might ask, sir, why? How did you know this fx is maximum? Because if the function is minimum also, the derivative must be 0. Yes, for that we have second derivative test, which we will not discuss here, because it is asked in the question. It has to be maximum. If it is maximum, the slope or the derivative must be 0. So what do we conclude from this particular example, students? We conclude that if you are given a given charge and you are asked to distribute it in two bodies such that the force of attraction or repulsion is maximum, then you should distribute it equally. So this charge q, we should distribute as q by 2 and q by 2. Is it clear, students? Okay, let us discuss one more question. Here goes the next question. You can see there is a square of each side A. There are 4 point charges, small q each, placed at the vertices. We have to find the net force on the charge placed at D. Let that force be Fd, that is question mark. So this is our question. Again, this can be solved by using principle of superposition. On D, which are the charges that will exert force? All these 3 charges. This charge will exert a force in this direction. I'll call this force as F of A. This is the force on the charge q at D due to charge q at A. That's why I'm using the symbol Fa. Likewise, this charge will also exert a force. Now, how did I know it will attract or repel? Is it given in the question? See, it is obvious it will repel because all the charges have identical nature, q, 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 q. It's not important whether they are positive or negative. If it's positive, all of them will be positive, and if one is negative, all of them will be negative. So in either case, they have to repel each other. So this force is I'll call it as Fc vector. The first one was Fa vector, and one more force that will be F due to charge at B. That will write as Fb vector. You can see this figure. Now the net force F on the charge at D, you know, students, it is given by which formula? From the principle of superposition, this will be given as the sum of the individual forces, that is Fa vector plus Fb vector plus Fc vector. Out of these 3 forces, can you guess which of the 2 forces have identical magnitude? Yes, that is Fa and Fc. Why? Because the separation between these pair of charges remain same. Let's write the values of these 3 forces one by one. Magnitudes I am writing. How much will be Fa? It will be 1 upon 4 pi epsilon naught. Now we know Coulomb's law, product of charges by separation between them. What is the product of charges? This is Fa. This is for this pair, so Q times Q, that is Q square. And what is the separation between them? A, so A is square. When you find Fc, again 1 by 4 pi epsilon naught, product of charges, that is Q square, by separation between them, that is A square. And when you find Fb, that is 1 upon 4 pi epsilon naught, product of charges Q square by. What is this separation? This is the diagonal of the square. So this is A, Pythagoras theorem you can apply. So this becomes how much? Root 2a. So root 2a whole square will become twice of a square. If I write this force as F, magnitude I will take it as F. Then you can guess Fc will also be F. What will be Fb? It is F and there is a factor 2 in the denominator, so I will write it as F by 2. So these are the values of these forces and the directions are indicated in the figure. What I can do, I can choose this direction as x-axis and the direction along Fc, I will choose it as y-axis. Now these two axes are mutually perpendicular to each other, so we can resolve all the forces along them, and therefore the net force Fd from equation 1 the net force Fd, its x component should be the sum of x components of these three forces. So it will be Fa x component, Fb x component and Fc x component. You need to have some preliminary idea regarding vectors which you have read in standard 11 students. How do we resolve a vector? Let me recapitulate if you have forgotten. If there be a vector, say a vector, and these are the coordinate axes, let this angle be theta, then its component along this direction we write as a cos theta and the component along this direction we write as a sin theta. So this is ax, this is ay, and so on. You see Fa vector. Fa vector is along which axis? It is already along x-axis. Therefore, Fa has total component along x-axis. The Fa x component is nothing but its magnitude. What is its magnitude? Its magnitude is f. Fb, what about Fb? Fb is inclined to x-axis. Can you guess what is this angle? Geometry says it must be how much? 45 degree. The x component of Fb vector will be its magnitude times cos of this angle, that is cos of 45 degree. Now what is the magnitude of that force? Its magnitude, Fb magnitude I have written here, f by 2 plus Fc. Fc is along y-axis. So what will be its x component? It will be 0. So how much will you get, students? We will get f plus f by 2 cos 45 is 1 by root 2, so we will have a root 2 factor here. In fact, if you see, there is clear symmetry in this particular question. If x component of the force is this much, we must get y component of the force to be same. Let's see it. So Fd y component. Fd vector is this one, so it's a y component. Quickly let's see. It will be Fa y component plus Fb y component plus Fc y component. Let's see one by one. Fa is along which axis? X-axis. So its y component cannot be present. It will be 0. Plus Fb y component. What is its magnitude? FB magnitude is f upon 2. And with y-axis, how much angle it makes? It makes an angle of 45 degree. So this will write as cos 45 degree. And if you think in terms of angle made with x-axis, we should write here sine 45 degree. Either way, the way you understand, you can write FCY component. Now FC is completely lying along y-axis, so its y component is nothing but f. And you can see this value and this value are same. So we will get how much? Again f plus, this is f plus this value, I will write as f upon 2 root 2. We have got the x component, we have got the y component. This is the answer to this particular question. Of course, if you are asked to find the magnitude, which I will leave it to you, magnitude of force Fd vector. You know, if there, let me again recapitulate that one. In vectors, and in fact, I would suggest all of you to briefly revise triangle law, parallelogram law, resolution of vectors, how do we find resultant of vectors, how do we subtract vectors, and later on we have discussed about dot product, cross product. All these things you should revise before attempting these things. I was saying, if there is a vector, say a vector, and its components along x and y axis are ax and ay, then the vector's magnitude we used to write as under root ax square plus ay square. So Fd vector, its magnitude should be under root its x component square plus its y component square. And what about direction? Direction is clear, it is making an angle of 45 degree with x-axis. That also can be stated in the answer. I am leaving this part. You can put the values of Fdx and Fdy and you will get the answer. Of course, since Fdx is equal to Fdy, this you can also write as Fdx square plus Fdx square. So twice of Fdx square, and therefore root 2 times Fdx, because it is square root, and put the value of Fdx, you will get the answer. So this is the solution to this particular question. Now I think I will stop here. Now before concluding, let me tell you to solve some questions like you can see NCERT example 1.6, 1.7. These you will find in page number 16 and 17. And in fact, before that, you will find some examples. You do from 1.1, example 1.1 to example 1.7. Most of the questions I believe you can solve, students. If at all some problems are there, one more thing, students, I feel you might get some doubts also while solving problems or while seeing these video classes. Your queries will try to solve. Let's see if you can set up some platform for your queries. This is your assignment, you should try it. By the way, if you get some trouble, you can freely mail me. Your queries at this email. I'll try to solve the queries if I could. Rest, I feel doing these 7 questions will bring in some confidence. You can solve the numericals from other textbooks also, H.C. Verma you can use. Next class, if there are some problems, we'll discuss them and we'll switch over to electric field. So before coming to the next class, please be prepared and prepare the lessons well. Thank you, students. Once again, our blessings will follow always wherever you go. Take care. See you in the next class.